Okay, today I'm going to show you how to solve this integral. Well, this is a pretty easy looking integral, right? So first you gotta know how to, what's the formula, how to solve the integral? Well, the formula is what? Yes. Well, I'm gonna write it right here. The integral from a to b of the function f of x dx. Well, first you gotta find the antiderivative, which is basically integrated. The antiderivative is gonna be capital F of x. So that means capital F of x prime capital F of x is the original F of x, alright? You're taking derivative. Alright. Now, when you get an antiderivative, you gotta plug in the upper limit and the lower limit. So you would write like this: the lower limit and the upper limit. This is equal to f of the upper limit first, which is b, subtract from f of the lower limit, a. So this is how you solve an integral. Deal with a problem like this. So let's do the same thing for this. Well, you know that the derivative of ln x is equal to 1 over x, right? So you integrate it, you get this. So if you integrate this, you get this. If you differentiate it, you get this. So the antiderivative of this is ln x. So this is it, capital F of x. Then you got to plug in the lower limit, a, which is 0, and the upper limit, b, which is 2. Plug this number in, you will get ln of 2 subtract from ln of 0. ln of 2 is just a finite number. E to the what equal to is probably going to be, I don't know. So you just leave like this. Don't leave as a decimal. No, because it's never ends, so you gotta leave like this. What is ln of 0 though? ln of 0 mean e to the what equals 0. If you think about it, e to the what equals 0. E to the 0 is not equal to 0. It's equal to 1. E to the 1 is e. So you gotta think. E is a finite number, 2.718, approximate. So there's no number raised to the power of anything that's equal to 0. Of course, right? Unless you like to an imaginary number, I don't know. So let's redo this again. So we don't know what e to the 0 is. Oh, this, it's not just a normal integral. This is an improper integral. The reason, here's the reason why it's an improper integral. First, let's graph this integral. This graph. So it go like this, and this up, right? But let's write the quadrant 1 first. Quadrant 1. Oh my god. So this is the graph y equal 1 over x. Technically f of x, because we're dealing with calculus. So we are going 0 to 2. Let's say right here is 2. In integral, you want to calculate the area, so like the area, right? And you see right here, if you plug in 0 in here, that'll be under 5. Because as you can see, the 0 never touch a graph. Because this is, what is it? A vertical asymptote. So technically, let's pick a number right here. Because it touches a graph, as you can see. Let's call this, well, this is a, the lower limit, so let's just call it a, because this is the lower limit and this is the upper limit. Okay? So basically, we are integrating integral from a to 2 of 1 over x. What is a though? Well, a gotta be a number really close to 0. But not exactly 0, because you know the 0 never touch a graph. And let's say 0.00001. That's not 0. So it definitely touches a graph, right? But let's just do this anyway. So this is equal to ln of x. And we are going to integrate from a to 2. So it's going to be ln 2 minus ln a. Well, a is actually 0. Because let's do the original question. Now, since it's the improper integral, you gotta take the limit. If you take the limit right here, this is perfectly fine, right? It's perfectly fine. But you take a limit right here, well, technically, it's still a, my bad. Technically, you take the limit from x approaching a, well, approaching 2, technically a from the right side. It's from the right side. So, on the right side, you're going to write a plus, like on power on the top, like that. So, you take the limit of this, is good. But you take the, oh my gosh, it's a, my bad. So, let's take the limit. So, this is ln 2 minus the limit of a approaching 0 plus of ln a. What is this equal to? You plug in 0, we already said, you know, yeah. But since we're taking limit from the right side, so 0 plus is not 0. It's a number very close to 0. So here's autograph of ln a. So y is equal to ln a, right? So from the 0 plus, so let's say like right here, so from the right side. So as you see, to the right, so from the right, you see it's going down, and it go down to reach, well, it go down forever. Forever mean infinity. So this basically, technically going down, so basically minus infinity. So it's ln 2, oh my god, minus, this whole thing is minus infinity. I just know why I just write a. Negative equal a positive. ln 2 is just a finite number. Well, any number plus infinity is infinity, right? So basically, this is equal to infinity. Or you can just say diverge. Because if it's converge, it means approach a number like 1, 2, 3, 4, 5, any number, like e, or 5.28 or 3.14 pi, not 3.14, but like approximation, yeah, right? So this is diverge. You can write diverge or infinity. Most people are gonna write diverge. It means it don't approach a finite number. I'm saying approach because we are taking the limit and some proper integral too. So let's say it's like a d and e, you can write diverge too. Do not write equal to d and e. That is stupid. Equal to does not exist. How you gonna write equal to when it doesn't exist? So yeah, that's it for this problem. Hope you guys learned something of it. If you don't learn anything from it, give me a like.